Hi everyone, welcome back. The learning goal for this video is to be able to write the symbols for the simple ions of representative elements. And so what do we mean by ions? Well, ions involve a transfer of electrons, and atoms will form positively charged ions when they lose electrons, and negatively charged ions when they gain electrons. You always have to remember that electrons have a negative charge, and that's why I always represent electrons as little e with a negative superscript there to remind me of the negative charge. So when an atom loses electrons, it's losing a negative charge, it will become a positive ion. And when an atom gains electrons, it gains a negative charge. So therefore, it'll become a negatively charged ion. So the ion just refers to charged species, and some will be positive and some will be negative. And once we gain this knowledge of determining the symbols for simple ions, then we will be able to form ionic bonds between positive and negative ions. And they are held together by strong attractive forces. So for example, sodium chloride, which is table salt, is a type of ionic compound that is formed between two ions, one positive and one negative. And when they are attracted to each other, they form what's called an ionic bond. And so we will learn that sodium makes a +1 ion and chlorine makes a -1 ion just based on its electron configuration. So your knowledge and fundamental chemistry core skill of deriving electron configurations and valence electron configurations will be helpful for this video. We will also learn about other types of molecules that form something called covalent bonds in a later video. But for right now, let's focus on ions, which will help us form ionic compounds. We'll discuss the difference between ionic and covalent here, just to distinguish once again the different types of chemical bonds. So chemical bonds are formed when atoms lose, gain, or share electrons. Those are going to be the big things here. So atoms can lose, gain, or share valence electrons to acquire what's called an octet. And so we're going to use the octet rule quite a bit in this class. All right, so ionic bonds occur when valence electrons of a metal atom are transferred to an atom that's a nonmetal. So your knowledge of identifying metal and nonmetal will be helpful here. And covalent bonds occur when nonmetal atoms share electrons to attain a noble gas arrangement. Or once again, we'll use that octet rule. So you'll see that in this video and later videos as well. So just the difference, ionic bonds, it's all electron transfer here. And then covalent compounds, or covalent bonds, the electrons are shared. And so this is just showing you a very general representation between ionic and covalent. So notice M stands for metal, N, M, nonmetal. So we will learn that to form an ionic bond, a metal will transfer its electron or electrons to the nonmetal to form an ionic bond. That leaves the metal positively charged and the nonmetal negatively charged. Whereas when we form a covalent bond, two nonmetals share electrons. So you see how they're kind of overlapping here, and that's a covalent bond. So ionic bond, electrons are completely transferred. Covalent bond, electrons are shared. So let's focus on positive ions. So in ionic bonding, ions form when atoms gain or lose valence electrons to form a more stable electron configuration. You're going to learn that every atom is trying its best to look just like a noble gas because noble gases are very stable. So it's really just, it always wants to be just like it. And that means it usually has 8 valence electrons, and that's where the octet rule comes in. So octet means 8. It's not always the case, but that's going to be your rule of thumb, is like these atoms want to be just like their nearest noble gas neighbor. So metals are the elements that will lose electrons. They're on the left side of the periodic table. We learned in a previous video that they have low ionization energy. So that means they're willing to lose electrons. And they readily lose one or more of their valence electrons to form a positive charge. And they will lose electrons until they have the same number of valence electrons as the nearest noble gas, which usually has 8 valence electrons. That's kind of the happy state there. So let's look at sodium as an example. Sodium's in group 1, which has 1 valence electron. Has 1 valence electron. Its nearest noble gas that precedes it, in this case here, is argon. Argon had neon. Neon has 10 electrons. Sodium has 11. So all sodium needs to do to look just like neon is to lose 1 valence electron. So if we look at this example here, originally, sodium has 11 protons and 11 electrons and has the electron configuration 1s2, 2s2, 2p6, 3s1. Now it has low ionization energy, which means it doesn't take a whole lot for it to lose its valence electron, 3s1. That is the valence electron. And when it does, it still has 11 protons because it's still sodium, and sodium has the atomic number 11, but now it only has 10 electrons. And if you do 11 minus 10, you get +1. So by losing that electron, we have a +1 charge. We always put the charge as a superscript right next to the symbol. And now it lost that valence electron, so now it has 1s2, 2s2, 2p6. It has 8 valence electrons, just like neon. So there's your octet rule there. It's a happy camper because it has an electron configuration just like neon. And all it had to do was lose a valence electron. If we look at magnesium, magnesium is in group 2, which means it has 2 valence electrons. And so if we look at this figure here, originally magnesium has 12 protons, atomic number 12, 12 electrons. So it's 1s2, 2s2, 2p6, 3s2. It wants to lose those 2 electrons because its nearest noble gas is neon once again. So if it loses 2 valence electrons, it gets, bingo, it's noble gas just like neon. So that's great. And if we look at the overall charge, we have 12 minus 10 is +2. So what you're going to learn and see the pattern is that group 1 metals form a +1 charge because they lose that 1 valence electron. Group 2 forms a +2 charge ion because it's going to lose those 2 valence electrons. So you're going to see patterns based on what group your element is in. Now, nonmetals in groups 15, 16, and 17 are on the other side, and they have high ionization energies, which means they don't like to lose electrons. They don't like to do that at all. And so therefore, it's easier for them to gain one or more valence electrons. And when they gain electrons, they form a negative charge. And they're going to gain electrons until they have the same number of valence electrons as the nearest noble gas. Once again, usually 8 valence electrons. And this is the core chemistry skill, being able to write positive and negative ions. And so if we look at the periodic table, 15, 16, and 17, group 17 has 7 valence electrons, and it only needs to gain 1 electron to become like the nearest noble gas. And so you will learn that group 17 elements will have a -1 charge. Group 16 elements need to gain 2 electrons, so they'll have a -2 charge to be just like their nearest noble gas. So oxygen needs to gain 2 electrons to look like neon. And group 15 elements will form a -3 charge because they need to gain 3 electrons to be like their nearest noble gas. Carbon will not form a charged ion because it will share its electrons, and we'll learn more about that later when we discuss covalent compounds. And transition metals are harder to predict. So we'll learn other tricks to predicting their charges. But for right now, group 1 makes +1, group 2 +2, group 15 -3, group 16 -2, and group 17 -1. Coming back again to the example of chlorine. Chlorine needs to gain 1 electron in order to look just like argon, its nearest noble gas. And so when it gains an electron, we have 17 protons and 18 electrons. 17 minus 18 is -1. So you can always determine the charge of your ion by adding the number of protons plus the number of electrons in your species. So here is a table of the formulas and names of some of the common ions. You can see the group 1 is lithium and sodium and potassium, all +1. Group 2, magnesium, calcium, and barium, all +2. Group 3, aluminum, 3+. Group 5 or 15, nitrogen, 3-, phosphorus, 3-. Group 16, oxygen has a 2-, sulfur has a 2-, and then group 17, they all have a -1 charge. I like the table on the next slide, which shows you examples of monoatomic ions and their nearest noble gas. And so you can see here once again, group 1 versus group 2 and group 3, group 15, 16, and 17. And these are the most common elements we'll work with. And they're monoatomic because it's just one element here. We'll learn more about polyatomic ions later. Now, understanding ions is really important to understanding our body. These are some of the ions that are important in regulating body functions. So for example, sodium is the principal cation outside the cell. Cation is just another word for a positive charged ion. Sodium cation is important for regulation and control of body fluids, and we can get that from salt, cheese, and pickles. Potassium is another principal cation outside the cell. It's also important for the regulation of body fluids and cellular functions, and we can get potassium from eating bananas, potatoes, orange juice, and milk. Calcium is a cation outside the cells. It's also found in bones. It's the major cation in bones, need it for muscle contractions as well, and we can get our source of calcium from milk, yogurt, cheese, greens, and spinach. And magnesium is another example of a cation. found outside the cells, also found in bones. It's essential for certain enzymes, muscles, and nerve control. And we can get magnesium from chlorophyll, nuts, and grains. So go ahead and pause the video, try the study check on your own, and then check your work with me when you're done. So we are asked to write the formula and symbol of an ion with 16 protons and 18 electrons. So first thing I like to do is I look up the 16 protons because I know the number of protons tells me the atomic number. And if I know the atomic number, I can identify the element. So the element with atomic number 16 is sulfur. So write the symbol for sulfur. And it has 16 protons and 18 electrons. So 16 minus 18 is what? -2. And so the way we represent ions in a symbol form, we usually draw the symbol, we write the number first, and then the charge after it. So this would be sulfur and then 2 minus the charge. And sulfur is in group 16, and we did say group 16 elements form a -2 charge. This makes sense because it gained 2 more electrons. Go ahead and pause the video, try the study check on your own, and then check your work with me when you're done. So we're going to consider the elements calcium and chlorine. Let's identify each as a metal or non-metal. So is calcium a metal or non-metal? It is a metal. It's an alkaline earth metal. Anything to the left of the gray ladder is a metal. So calcium is a metal. And chlorine's on the opposite side to the right of that gray ladder. So chlorine is a non-metal. You can see that here. Chlorine is a non-metal because it's to the right of the gray ladder. It's labeled as a halogen, but halogens are non-metals. State the number of valence electrons for each. So calcium has how many valence electrons? So it's in group 2, it says 2 valence electrons. So group 2, it has 2 valence electrons. I'm going to abbreviate that as VE negative, so valence electrons. And what about chlorine? Chlorine is group 17, so it has 7 valence electrons. State the number of electrons that must be lost or gained for each to acquire an octet. So calcium, is it going to gain 6 electrons or is it going to lose 2 electrons? Good, it should lose 2 electrons. It requires a lot of energy to gain 6 electrons. So it's a lot easier to lose 2 electrons. And is chlorine going to lose 7 electrons or gain 1 electron? That's correct. It's a lot easier for it to gain just 1 electron. So with that knowledge, write the symbol, including its ionic charge, and name of each resulting ion. All right, so the symbol for calcium, we've already kind of written there. If it loses 2 electrons, it becomes calcium 2+. Chlorine gained an electron, so it becomes chlorine -1. And we always kind of drop the 1. If it's a +1 or -1, we just write the symbol positive or negative. We don't write the 1. Now the name of it, we will learn when we do some more nomenclature in a later video, but for the cations, the positively charged ions, we write the full name, so calcium. And for the anions, the negatively charged ions, we write the name, chlorine, and then we drop the INE and we replace it with IDE. So this becomes chloride. But we'll discuss that more in a later video. But that would be the name of that resulting ion is the chloride ion. All right, thank you for watching. And as always, email me with any questions.